length 4 increasing subsequence. Let's look for length 4 increasing subsequence. Can anyone prove to me that this length 4 increasing subsequence? Just from this picture, I mean, we constructed it in a certain clever way, right? There are these 3 fellows, then the next 3 fellows, then the next 3 fellows. So if I mean, this is maybe pigeonhole principle again, if you wish, just from the way we constructed it. If I had a subsequence of length 4, what can you control? So look at, think of these as the 3 boxes of your pigeonhole, 3 pigeonholes. Or maybe that's not correct. Each of these rows only has, I mean, each of these blocks. Suppose I had a subsequence with 4 terms, that subsequence cannot fully live within any one of these blocks. Okay? These blocks only have size 3. So if I take 4 terms, what will happen is I must pick things from 2 different blocks. There must be terms coming from 2 different blocks. Okay. Now, is that possible from the second block? I want to move on to the next question, which is number 23. Okay, so question 23 is sort of interesting actually. So it says, whenever, so let me write this out, show that. So whenever 25 girls and 25 boys are seated, around the circular table, okay, so let's show that whenever 25 girls and boys are seated around the circular table, there is always a person whose girls are boys. Okay, I mean, it's again one of those maybe not pigeonhole principle in some, in a classic formulation, but rather an application of the general philosophy that somehow if you have not enough space and you sort of have to pack more objects obeying some constraints, then there will always be some forced configuration. Something will come together. Like for example, the pigeonhole things will have to fall into the same box. Here, it's philosophically the same sort of thing. Okay, so let's think about how we would do this problem here. So I want to seat them all in a circular table. 25 plus 25 are 50 of them in all. So I draw a circle and think about seating 25 boys and girls around this table. And what I want to say, so there is a person, so it doesn't, the person could be a boy or a girl, but what you want to show is that there is somebody seated around the table such that on both sides of that person we have boys. Okay. So that's the thing that we need to show. Okay, so one way to show things like this is, one should sort of play with the various configurations for a little while. So let's maybe proceed by contradiction. So that we want to say, suppose this did not happen. Suppose this is not. There is nobody for whom both neighbors are boys. Then what does that mean? So let's try and see what such configurations must look like. So I'll first start out by drawing one such configuration, and let's start with there is a boy, let's say B. Okay, now what is the thing we assume? Suppose not. So I said let's assume the contrary, suppose not. So what does that imply? It says, so let's look at the next location and the one after that. So look at the location that's 2 steps away. Now, what can we say about this location? Who's seated in this location? Assuming that, I've made this assumption. Suppose this is not true.
Well,
It has to be a girl, right? Because we are assuming that there's nobody who will have boys on both sides. So if we assume the contrary, then that location is occupied by a girl. Okay, and so on. In fact, this is more generally true that any boy occurring, seated anywhere, 2 steps away from that boy must be a girl. In fact, it's 2 steps in both directions if you wish. So there is also, it's after all a circular table, so you can actually conclude the same thing about the other side as well. That's a girl here also, right? Okay, very good. So let's look at the next thing. So let me look at this this position here, which is between the boy and the girl. So of course I don't know who's sitting there. It could be either possibility. It could be a girl or a boy. So let's take both cases. So let me take case 1 first, which is maybe that there is a boy sitting here. Okay. So if there is a boy sitting there, then let's make the same conclusion again. What can I conclude? What do I know about this?
well,
That's a girl again. And well, same thing. If I move 2 steps to the right of this boy, that must be a girl again. Right? Now, okay, what does that imply beyond this? So again, so somewhere, I can just continue this process once more. So let's see. So what this implies really is the following, that, so let me go one more step again. So again, here I don't know who's sitting. It could be a boy or a girl. But if it is a boy, for example, then I can conclude the same thing, that 2 steps away from them has to be a girl, and so on. Okay, so maybe that's so what is it that I want to say? So I want to claim, well, I want to make the following observation, that there are many cases. I didn't quite try to write all the cases out. So if you play with it a little while, this is what you realize, that if there is B somewhere, then 2 steps away must be a G on both sides. Okay. So what this probably means is the following. If we do the following, let's take this circular table and we delete all the positions where girls are sitting. So let's just keep only the positions where the boys are sitting. So just forget about where. So of course they could be adjacent to each other and so on. Okay, so is it clear what I've done? I've just taken the positions where the boys alone are sitting. The remaining are just empty at the moment. The remaining are all empty positions. So I've sort of removed the girls from the picture at this point. But given this configuration, what can I just conclude? I've just realized the following, that if I take this configuration and I sort of rotate it 2 units to the right, if I sort of rotate it 2 steps, I mean clockwise or anti-clockwise, let's say, if I rotate this configuration 2 steps anti-clockwise, then what will I generate? What will I see? So let's take the same thing. So I have B here. So I rotate it 2 steps anti-clockwise, means instead of looking at this position, I want to see who's here. Instead of this boy, I want to see who's here. Instead of this boy, I want to see who's sitting 2 steps to the right, and so on. And that we have just realized must all be girls, right? So if you know where all the boys are sitting, 2 steps, you know, rotated anti-clockwise from there, there must be a girl necessarily, right? So that sort of forces where the girls are sitting. Since there's an equal number of boys and girls, 25 each, if you know where all the boys are, then it sort of tells that the girls must be sitting, right? Okay, so in some sense, this seems to say that okay, we need to conclude from here. So my own thought was that the configuration.
If you just continue it 25 times, you'll see that the boy must be the girl.
No, but continue meaning.
So you will get, if you shift 2, you will get a girl. If you shift 4, you will boy.
No.
Yeah, that's what you're shifting.
It's,
To the same
yeah.
But then, if, yeah, I mean, shift the same direction.
Correct. No, but I meant.
Oh.
See, we only know that if there is a boy, then there is a girl 2 units.
Oh, I
clockwise.
see. So
but then it also applies.
Thing is wrong.
No, but it also applies clockwise.
Correct. It
What
also
you're saying
applies
is
that.
right. Okay. Thanks. Yeah. Okay, that sounds good. So basically, it says if you know the configuration of boys, then if you rotate it 2 units, either clockwise or anti-clockwise, what you will get is the configuration of girls. That's the only thing that's possible. But like Raghavan says, that just says that if you rotate, you take the configuration of girls and you rotate that 2 units clockwise and anti-clockwise, then it gives you the configuration of boys. Okay, so that's the broad model here. Okay, so the configuration, the B configuration, meaning where they are seated, gives rise to the G configuration of girls in one of the following 2 ways. You can do +2 clockwise or +2 units anti-clockwise, or let's say ±2 clockwise. You can rotate it in any which way, and therefore the same thing from the girls. If you rotate 2 units clockwise or anti-clockwise, you get back to the configuration of the boys. Okay, but then the contradiction is because 25 is an odd number. Okay, why? Because now let's just go back to our original situation. Take this point B time, what is B and so on. By 2, it switches B to a G. So if you get the 25th, I do. So